Hi, and welcome to a new Innovation Coffee Break. My name is Thorsten, and today my colleague Steffen and I will share some exciting news about a new tool designed to enhance your verification and validation activities for automated driving functions. The Traffic Virtualizer is a tool for analyzing real-world traffic recordings to extract ODD-related knowledge. On top of that, it generates scenarios that can be used for simulation. In short, it's a tool to virtualize real-world traffic for simulation-based verification and validation of automated driving functions.
Okay, that sounds great. But before we dive deeper into the tool itself, can you explain why such a tool is a significant benefit for engineers?
Sure. In the development of ADAS and autonomous driving, simulation is crucial, especially for higher levels of autonomy like level 2+, level 3 or level 4 systems. Only by making use of highly scaled and parallel simulations, you can test the billions of kilometers and different scenarios that are required to prove safety. But if you use simulation, one major question is how to ensure and especially prove trustworthiness of the simulation. Who tells me, and finally also the authorities that are responsible for type approval, that one can trust the simulation model, that it reproduces the real world on a sufficiently accurate and realistic level? Therefore, it's essential to enhance processes for virtual homologation with real-world data, especially for the scenarios. There are two particular topics I want to briefly discuss here. The first one is to build up a library of realistic, representative, and relevant scenarios. By systematically analyzing the real-world traffic situations in the continuous flow of test drive recordings, you can build up knowledge of the traffic scenarios in the target ODD. This includes, for example, the categorization of traffic situations according to abstract scenario definitions, identification of previously unknown categories of scenarios, and the extraction of scenario parameters. All of this gives you a holistic statistics on the traffic in the target ODD. The logical scenarios generated based on the real-world traffic and the extracted statistics finally serve as a starting point for scenario-based testing in simulation. All this data, the condensated real-world evidence, and the results of the virtual scenario-based testing, this is finally the foundation for coverage analysis and residual risk estimation. The second topic is model validation. By comparing real-world data with simulated data of the same scenario, it is, for example, possible to prove that the system under test behaves sufficiently similar in real-world and in simulation. For both of the mentioned topics, the Traffic Virtualizer can help. So now, Steffen, it's time for you to take over and give the audience a demo of the tool itself.
Yeah, thanks Thorsten for this nice introduction. Now I will take over and show you the tool. The Traffic Virtualizer is integrated in our tool Aurelion, which is our tool for 3D visualization and physical-based sensor simulation. For the demo, we are using a dataset from the A33 here in Paderborn that was created with our dSPACE sensor car. A sequence of the recorded data could also be seen on the slides of Thorsten. To use the recording of the Traffic Virtualizer to generate virtual scenarios, an object list must be created from the recording. This object list can then be used with a suitable open drive file to create scenarios. Before we create scenarios, we can have a look into the previewer to make sure that the data is useful and visible correct. Now we are sure that the data is useful and we can import the object list and the open drive. During the import, several checks are carried out to check whether the data is logical and semantically correct. After the import is successfully, we can then use the object list and the corresponding road to generate scenarios out of these files. We can easily select the object list and the road from the drop-down menu. The Traffic Virtualizer will generate two different types of scenarios. a replica scenario, which is trajectory-based scenario directly fitting to the object list description, and a logical scenario. For a logical scenario, the Traffic Virtualizer will analyze the object list according to specific patterns which are predefined and used to find types of scenarios, for example, a cutout scenario. Here you can see an example of such a template. The scenario generation process is now finished and we can have a more detailed look in the results and the scenarios. The results can be opened directly here. In the results folder, we can find the replica scenario, the logical scenarios, and a parameter file which extracts important variables to describe the scenario. We can now use the generated scenarios to visualize them in a preview or else in Aurelion. For this, we need to import the scenarios. We can do this directly in the Aurelion Manager and import the scenarios here. For example, the logical scenario cut out. Here we can see an open scenario preview for this scenario. In this preview, we have the possibility to also change the parameters to variate the scenario. But now we want to have the visualization also in Aurelion so that we can use the scenario for closed loop testing. For this, we can go to the simulation part and synchronize the scene to Aurelion and see the results. I'm using here a new ASM traffic model that natively supports Open Scenario. This model will be officially released in summer this year. But what if we want to scale up the simulation of the scenario variants to make testing even more efficient and faster? Then we have also the possibility to use Open Scenario and Open Drive files in our tool Simfera. Simfera is our cloud-based solution to scale up our tests. For this, we will switch to our tool Simfera. Here you can see that it has a quite similar structure we have in the Aurelion Manager. In the scenario section, we are able to upload the scenario generated by the Traffic Virtualizer and use it for scaled execution in the cloud. We can use the scenario then in a test suite to execute different scenarios in parallel by varying the scenario parameters in a certain type. I have prepared this before. We can have a detailed look into the results and see that the simulation really scaled up here. We are able to simulate round about 1 hour 30 in like 15 minutes. So this was all from my side. And now I will hand back to Thorsten.
Yeah, thanks for the great tool demo, Steffen. We provide a service for scenario generation already since quite some time. Now there's a tool. This has a lot of advantages for validation engineers. For example, the data remains in your infrastructure. There's no need to provide the data to external parties like dSPACE. This results in much less efforts for NDAs or data processing agreements, for example. Secondly, you can immediately process the data when it is available. and this saves a lot of time before making use of the data and the scenarios in your V&V activities. And finally, you can also integrate the tool into your data-driven development pipelines due to its APIs and the cloud-compatible infrastructure. So that's it. Thanks for watching.
And if you want to learn more about the Traffic Virtualizer, Aurelion, ASM or Simfera, feel free to contact us and we can have a discussion about your needs and how we can help you to boost your V&V activities with real-world data and scenarios.
dSPACE, your partner in simulation and validation.